Alright, welcome back everyone to another video. Today we'll be doing exercise 1I. Now 1I, we're actually introduced to the binomial theorem and we're doing a bunch of combinations of the sorts. Let's get started. Alright, number 1 is asking us to write the first 4 terms in the binomial expansion of each of these terms. So A is going to be x minus x divided by 3 to the power of 11. And remember, according to the binomial theorem, this is just going to be equal to n choose 0 times a to the n plus n choose 1 times a to the n minus 1 times x. And then so forth, we're just going to do and choose 2, and we can see the pattern going on here. Okay. So that means for A, we'll have 11 choose 0. Oh shoot, I wrote that wrong. That's supposed to be a 1. And then 1 to the 11 plus 11 choose 1 . You have 1 to the 10th, which is just 1, negative x divided by 3, 1, plus 11 choose 2, 1 to the 9th, negative x divided by 3 to the 2nd, plus 11 choose 3, 2, 3, 4. Just asking for the first 4 terms, yes, okay. 1 to the 8th times negative x to the 3rd. Okay, now we're going to have to do a bunch of simplifying here. 11 choose 0 is just equal to 1 times 1 to the 11th, which is just 1. And then 11 choose 1 is going to be equal to 11 times 1 times negative x over 3 plus 11 choose 2. If we remember our rules here, we're going to be left with 7 times 6 over 2, and that's just the simplified version of that. Times, oh wait, no it's not, I messed up, looked at the wrong thing. I actually don't know what that's going to equal off the top of my head, but we'll just write it like this. And then once you simplify all of this, you should get 1 minus 11x over 3 plus 55x squared over 9 minus 55x cubed over 9. And those are the first 4 terms, so we're done with that. Let's go on to B. B, we have 1 plus x divided by 2 over 7, which according to the binomial theorem is just going to be equal to 7 choose 0, and then 1 to the 7th, plus 7, choose 1. 1 to the 6. X divided by 2. 1. Plus 7, choose 2. 1 to the 5th. X divided by 2 over 2. And 7, choose, that's not a 3. 3, 1 to the 4th. X divided by 2 cubed. Well, dot for 7 terms, which is asking us to find the first 4 terms, so we're only concerned about this. And that's going to end up simplifying to 1 plus 7 over 2, well, 7 times x over 2, plus 7 times 6. This is where that was coming from earlier. I was looking at the wrong notes. X. And I'm still looking at the wrong notes. Wow. Plus 21x squared over 4 plus 35x cubed over 8. And that is our answer. This matches over here. Well, that matches over there, over here, and over here, and over here. That's our answer. Right, on to C. C asks us to find the first 4 terms of this binomial expansion. I think that's an 8. Okay. Here we'll have 8 choose 0. And we actually do have an x here now, so it's going to be x to the 8th plus 8 choose 1, x to the 7th, 2 divided by x to the 1, plus 8 choose 2, x to the 6th, 2 divided by x to the 2nd, and for our last term, 8 choose 3, x to the 5th, 2 divided by x cubed. Okay, and this will simplify to just x to the 8th plus 16x to the 6th plus 112x to the 4th plus 448x squared, which is that term. That is our answer. On to number 2. I'm not gonna show the math for most of these just because it's simple math. The issue is it's just gonna take forever for me to write it all out. If your teachers want proof, just remember what the definition of a combination is. Don't forget about that. Okay, on to number 2. Number 2 is asking us that in each of the following binomial expansions, write down the required terms. Okay. That's doable, so let's get started. Also, whoops, hold up. That's not supposed to be an N. That's supposed to be R here. Okay, so first asking us to write down the 5th term of a minus 2b to the 10th. Okay, since there's going to be 10 terms, the 5th term in this case is going to be 10 choose 4, because remember when we're counting up we include 0 here, so the 5th term will technically just be 4. I know that sounds a bit funky, but let's continue. Remember, our a here is just going to be raised to the power of r, which is 4, Then our negative 2b is raised to the power to 10 minus 4, which is equal to 6. Which means that the final answer is, I'll actually write this one out. 10 factorial over 4 factorial, 6 factorial, a to the 4th, 2 to the 6th, which is 32, b to the 6th, which is equal to 3,360, a to the 4th, b to the 6th. Okay. Oh shoot, oh. This is equal to 64, right? Keep writing the wrong numbers. Okay. And that's the 5th term. Okay, 2b. We have the 3rd term of a plus 4 divided by a squared, the power of 11. The 3rd term, this is going to be 11 choose 2. And we're going to have a wait a minute. Wait a minute. Give it a second, everyone. Sorry. (11 minus 2). Geez, and that's equal to 9. Okay, that means that this one was wrong. This should be, if I can erase out of here, that should be 6, and this should be 4. I feel like Mr. Shiner making mistakes. No hate to Mr. Shiner, of course. I also just like might be completely wrong, but I'm like, that's correct. No, I'm not wrong about that. Okay, because it's n minus r for your 1st term. Okay, and then we have 4 divided by a squared to the 2. And that's going to just simplify to 880 a to the 5th. A to C. We have parenthesis, I lost it. Okay, parenthesis x minus 2y over x. And I think that's the power of 8. It's asking us to find the 4th term, so this one's going to be a 8 choose 3. X to the 8 minus 3, which is 5. And then 2y over x to the 3rd. And writing this out, we'll get 8 factorial over 3 factorial, 8 minus 3 factorial, so 5 factorial times x to the 5th, 8y cubed, x cubed, which simplifies to negative 400 Oh, I missed that this is negative. Okay, that explains why that wasn't working. Right, negative 448 x squared y cubed. Okay, on to number 3. We'll have to find the term independent of x in the expansion here. Okay. Now, when it asks for the term independent of x, that's basically just asking for the term where x is raised to the power of 0, so we just get the coefficient. It's going to be the coefficient that does not include x here. And to do that, we're going to have to multiply x to the 12 minus r, because remember, this is just a little thing going on. 12 minus r times, and we can actually just take out this 2 for now, since we're just worried about these terms over here. 1 divided by x to the 2 is just x to the negative 2, and that's getting multiplied by r. And this is going to be equal to x to 0. When we're multiplying exponents, just remember we're adding them up. That means that 12 minus 3r is equal to 0. Minus 12 on both sides divided by negative 3, you get r equals 4. And is that all it's asking? Well, no, it's not. We need to find what the actual term is. So then if we know r equals 4, we can come back over here. We can do it 12, choose 8. And the reason why it's... No, it should be a 12, choose 4, no? R equals 4. No, okay, I understand it now. I understand. Okay, it's got to be 8. Reason being is if we come back over here, when we have x to the 8th, that's getting multiplied by x to the 8th. That's going to equal 1. Our r is going to be whatever our second term is going to be in. So our second term is, 1 divided by x squared to the 4th. That means the first term has to be x to the 8th. Minus 2 by x squared over 4. And after doing math, you'll get that equal to 7,920. On to number 4. Number 4 asks us to use the binomial theorem to expand 2 minus x divided by 5 to the 4th. Hence, find the value of 1.99 to the power of 4. Correct to 5 decimal places. Okay. This one's going to be a struggle, but it should be fine. First thing, you just expand out this entire thing. So if you can start, how can we start this? We can start by getting a 4, choose 0, 2, this is the 4, negative x divided by 5 to the 0, plus 4, choose 1, 2 to the 4 minus 1, 3, negative x divided by 5 to the 1, plus 4, choose, I need to start writing smaller, 2, 2 to the 2, negative x to the 5th, that's supposed to be a 2, plus 4, choose 3, 2 to the 1, negative x divided by 5 cubed, plus 4, choose 4, 2 to the 0, times negative x divided by 5 to the 4th. And here is where we need to start simplifying everything like crazy. I'll actually show the math for this one. Let me just get a calculator out. Desmos.com. Okay. 4, choose 0. is going to be equal to 1, and then 2 to the 4th is equal to 16. That's just equal to 1. Four choose 1 is going to be equal to 4. 2 to the 3rd, 8. Negative x to the 5th. Plus 4 choose 2. Let's see, where's my calculator when I need it? Four choose 2 is equal to 6 times 4 times x squared divided by 25. 4 choose 3. Did I do something wrong here? No. 4 choose 3 is going to be equal to 4 times 2 times negative x cubed over 125 plus 4 choose 4, which is equal to 1 times 1 times x to the 4th over whatever 5 to the 4th is. I think it's like 625 if I remember. Yeah, that looks right. And all of this is going to end up simplifying to 16 plus 24 negative 24 over 5 for 24 x squared, or where'd that x go? Over 25 plus negative 8x cubed over 125 plus x to the 4th over 625. And that's our answer, right? Yep, that is our answer. I'll just start it off this term up here and just make it look a bit simpler. Whoa. Hold up. Pause our horses here. That is not 24. 8, 16, 24, 32. That's where we went wrong. And by we, I mean me. Okay. Simple math error. It's fine. It now wants us to find what 1.99 to the 4th is. Remember, this is just going to be equal to 2, which is our original expression up here. Look at that, 2 minus x divided by 5. We need x divided by 5 to be equal to 1 divided by 100. That means x is going to be equal to 0.05. This is going to be equal to 2 minus 0.05 over 5 to the 4th. Which means that since this is our x, we just plug this back in here. This comes over here, so we'll have 0.05 to the 4th divided by 625 minus 8.05 cubed divided by 125 plus 24x squared divided by 25 minus 32.05 divided by 5 plus 16. And I'm not going to show every single step of it, but it's asking to 5 decimal points. And once you plug this into a calculator to 5 decimal points, you get 15.68239. And that is our answer to 5 decimal points. Okay. On to number 5. Let me zoom in a bit. Number 5 is asking us to find the term an x squared of the expansion. So now, when you look for x squared minus 1 divided by x, is that 6? Yep, okay. We want to find x squared, so that means that our x coefficients are going to have to multiply to equal 6. Or not our x coefficients, but our x exponents. We know that in any binomial expansion, it'll be set up like this. 6 minus r in this case. And negative 1 divided by, or 1 divided by x is just equal to x to the negative 1 times r, which has to equal x to the 6. That gives us 12 minus 2r times x to the negative r equals x to 6. We're multiplying exponents, we just add them together. This means r is equal to 2. That is not what I meant to write. R equals 2. Okay, and now we just need to plug it back over here. So we'll end up having 6 choose 2. 6 minus 4 for this exponent, and negative 1 divided by x to the second. 6 choose 2, just going to be equal to, let's see what Desmos says, 15. So we'll have 15 times x to the 4th. Nope. Yeah, x to the 4th. Right? Oh, shoot. Oh my. These little errors get you so messed up, I'm telling you. It's supposed to be 6 minus 2. So we'll have x squared to the 4th, which is just going to be equal to x to the 8th times 1 divided by x squared, which is equal to 15x to the 6. Okay. That's our answer. Time for number 6. I really hope you don't hear the lawnmower in the background. I don't know who's mowing their lawn in this weather, but whatever. Alright, 6 split into 2 parts. Part A is asking us to expand out this binomial. That's x, okay. Some of this is just busy work, I tell you. But remember our whole shenanigans we had. Binomial theorem, we have 5 choose 0, x to the 5th, plus 5 choose 1, x to the 4th, y divided by x, plus 5 choose 2, x to the 3rd, y divided by x squared, plus 5 choose 3, x squared, y divided by x cubed, plus 5 choose 4, x to the 1, y divided by x to the 4th, and our final one, 5 choose 5, x to the 0, which is just equal to 1, y divided by x to the 5th. And once you actually do the math for all of that, you'll end up getting x to the 5th plus 5x cubed y plus 10 xy to the seconds plus 10y cubed over x plus 5y fourth over x cubed plus y to the 5th over x to the 5th. That's our answer for 6A. 6B. Find the coefficient of x cubed xy. x cubed xy squared, and the expansion 2x plus y x plus y divided by x to the fifth, I think. Oh geez, they always make these hard to see. Okay. Remember what we said earlier. This entire thing is just going to be equal to what we just proved earlier. So that means you can set this as 2x plus y. And I am not rewriting this entire thing, so just give me a second to lasso this all around. Just make sure nothing got like taken away. Okay, yep. And we know we're looking for the term x cubed y squared and to get that term we're gonna have to look at this number right here since our only x cubed number. Y comes into all of these at one point, and look at that. That'll give us y times 5x cubed y, which is then equal to 5x cubed y squared, and it's asking for the coefficient, so co is equal to 5. Okay, look at that, we're almost done. No, we're not. That was a lie. I'm gonna switch up colors because I get bored of just plain old black every time. This red actually kind of sucks, I won't lie. Give me purple. Okay. 7. Write in factorial notation all of these. The coefficient of x to the fourth of the expansion 1 plus x. Can't read that. Oh my god. N minus 1. Okay, simple. Looks like we're just looking for n. Choose. Is that a plus 1 or a minus 1? It's a plus 1. Right? No, it's a minus 1. Oh my god. I'm losing it. wait. No, that is a plus 1. Oh my god. So since asking goes for the fourth one, there's only one x term here, so we know r is going to have to equal 4 for this to be true, so we can write it like that. And since it's just asking for the coefficient, this is going to be our answer. How do you... There we go. This is just going to be our answer since 1, it won't matter what you put that to the power of, it'll always equal 1. And it wants it in fractorial form. So remember just the binomial equation for all of this. N plus 1 minus 4, which is just equal to n plus 1 factorial over 4 factorial and minus 3 factorial. That's our answer. I like this purple. I really hope you don't hear all that noise that's going on upstairs. I really hope my mic is loud enough too. I like to switch which mic I'm using from time to time. 7b, I like this exercise. I'm able to actually explain it to a great degree and do the problems easily. Okay, find the coefficient of x cubed and the expansion 1 plus 2x, and then think that's to the third. No, that's just n. Okay. Okay, since we want to find the third coefficient, r here is going to have to equal 3, since this is our only x term, so we'll have 3. And we do have a coefficient here, unlike last time on x, so we're going to have to actually do some math. 1 to the n, which is always just equal to 1, times 2x to the third Okay, so then we'll have n here times 8x cubed. We don't care about the 8x cubed, so it's just going to leave us with 8 times, we don't care about the x cubed. 8 times n choose 3, which is equal to 8n factorial divided by n minus 3 factorial times n factorial. If I'm not mistaken. No, 3 factorial. That would have been bad. And that's it. Is there a way to simplify this? Well, I guess there is, but that works. Okay. On to 7c. Find n given that these two coefficients are equal. What two coefficients? What is it talking about? Oh, it's talking about B and C's coefficients. Okay, well, let's get to work then. In that case, we're just going to have to set the two equations equal to each other. So we'll have 8n factorial divided by 3 factorial. N minus 3 factorial is equal to, what did we have earlier? Okay. N plus 1 factorial divided by our thing for A. Give me a second. Okay. Minus 3 factorial. Looking at this, I'm thinking, I think we have to cross multiply here, maybe. Yeah, it looks like it's. Yeah, we're gonna have to cross multiply, dang it. Okay. We'll have 8 n factorial times 4 factorial n minus 3 factorial is equal to n plus 1 factorial 3 factorial n minus 3 factorial. Okay, we can take out these two factorials to get left with 8n factorial. 4 factorial is equal to n plus 1 factorial 3 factorial. Let's go ahead and try to take out an n factorial from both sides. You know that this is just going to become n plus 1 times n factorial times 3 factorial, which means we can take out that from both sides, and then we're left with 4 factorial is equal to 3 factorial n plus 1. Remember, this is equal to 4 times 3 factorial, so we can cancel that out from both sides, get 8 times 4 is equal to n plus 1, which means that 32 is equal to n plus 1, and n is equal to 31. This means that the coefficients are equal when n is equal to 31. Okay. There we go. On to 8. It's also split into 3 parts, so 8a. And we have to express the square root of 3 minus the square root of 2 to the 5th in the form of a square root of 3 plus b square root of 2, where a and b are elements of integers. Okay. Let's go ahead and get started. Once again, we're just using binomial theory here. I'm gonna have to write this entire thing out, unfortunately. So we'll have 5 choose 0, square root of 3 to the 5th, plus 5 choose 1, square root of 3 to the 4th, negative square root of 2 to the 1, plus 5 choose 2, square root of 3 to the 3rd, times negative square root of 2 to the 2nd, plus 5 choose 3, square root of 3 to the 2nd, times negative square root of 2 to the 3rd, plus 5 choose 4, and you know how it goes from there. Plus 5 choose 0, no, 5 choose 5. That's supposed to be a 4 right there. Okay. And now we just have to simplify each of these terms. That's just going to be 1 times square root of 3 to the power of 5. And then this is all just me plugging it into a calculator, or plugging. Yeah, this is just me plugging everything into a calculator, basically. 5 choose 1 is going to be equal to 5 plus 10 plus 5 choose 3, which is equal to 10 again. And 5 choose 4, which is equal to 5. And 5 choose 5, which is equal to 1. Okay, after doing all the math for this, you should get 9 square root of 3 minus 45 square root of 2 plus 60 square root of 3 minus 60 square root of 2 plus 20 square root of 3 minus 4 square root of 2, which is just, when you combine all the like terms, 89 square root of 3 minus 109 square root of 2. That's our answer. On to 8b. Just give me a second to like stretch and everything. We're almost done with Unit 1. Thank God. 8b says to express the square root of 2 plus 1 divided by the square root of 5th minus the square root of 5th, or 1 divided by 5th to the power of 4. Okay, first, things first, let's rationalize this equation to get this. Okay, and then basically just doing what we did last time. We do 4 choose 0, 4 choose 1, 4 choose 2. I'm not going to write all the 4 chooses out, so I'm just going to get straight to simplifying. The square root of 2 to the 4th plus 4 choose 1, which is equal to 4, Square root of 2 to the cube. Negative 1 over... I just rationalized. Let me keep that rationalization. Plus 4 choose 2, which is equal to 6. Four choose 3, which is going to be equal to 4 again. I forgot to include a negative in that one. And 4 choose 4, which is equal to 1 times negative square root of 5 over 5 to the 4th. Okay, and then once you simplify everything, you should get 4 minus 8 square root of 10 over 5 plus 12 over 5 minus 4 divided by the square root of 10. 25 plus 1 divided by, that's supposed to be a 25. 25, which in the end just simplifies to 161 over 25 minus 44 over 25 square root of 10. That is our answer. On to 8C. Okay, great. 8C is asking us to find two binomial expansions now. Isn't that fun? Let's get started. We have 1 plus the square root of 5 to the 7th minus 1 minus the square root of 5 to the 7th. Sometimes I'm tempted to use Pascal's triangle and solve all these. I might still do that actually. You never know. Okay, I'm looking for an easier way to do this, but I think we're just gonna have to find both of the expansions, unfortunately. I'm thinking maybe I can multiply them by 2 since there's 2 of them, but what's a negative 5th root? So it's not gonna work, right? Yeah, it's not gonna work. Wait, maybe it does end up working. Let's think about this. I think it actually does end up working. We can just get the combination of this one, but remove a certain exponent here. Since whenever this is, say like we have, negative 5 to the 7th. That's obviously gives us a negative number, but that gets canceled out by the 5 to the 7th over here, no? It does. Okay, now I won't make it too confusing. Let's just find both of the combinations. So we have 7 choose 0 of 1 to the 7th plus, we're going to start with our left hand side, and by left hand I mean like this little thing. Just our first binomial expansion. We have to write this small into the 6. Plus 7 choose 2 to the 5th. That's just going to be equal to 5. Whoa. Starting to mess up. It is negative, right? No, this one's positive. This one starts positive. So I'm going to choose 4. Fifth. So I'm going to choose 6. 1 over 1. Plus 7, choose 7. Okay, I'm not going to solve that yet because I want to write out this next one and see if there is a pattern. So this is going to be minus to the 7th. To the 5th. Negative. I'm trying to see a pattern here. I really am, but... Okay, I found the pattern. There we go. Okay, there we go. We got the pattern. We got the pattern. Okay. The thing is, if this is a negative square root of 5th, this is a positive square root of 5th, right? They're both going to cancel out when we start subtracting everything. But this is being subtracted, so that means this is becoming negative. So that means whatever was positive is actually going to end up turning negative. And for our square root of fifths, that's all of our even square root of fifths. So that's just going to cancel each other out. So this entire thing just ends up canceling out unless it's odd. So this cancels out. I don't want to erase it. Hold up. Yeah, okay. We found the pattern. We finally found the pattern here. This, every odd r is just going to end up equaling our original odd r. And our even odd r's, our even r's are just going to cancel out with the original one since there's a negative over here. So in that case, there we go. We can write this as 2 times 7, choose 1. I'm just going to stop including the ones here for a bit. Square root of 5 plus 7, choose 3. Cube root of 5 plus 7, choose 5. Cube root of 5 plus 7, choose 7. And the square root of 5 to the 7th. There we go. There's our pattern. This is just equal to our original equation in binomial expanded form. And we'll have 2. 7, choose 1 is just 7 to the square root of 5 plus 7, choose 3, which is 35. Plus 7, choose 5, which is 21. Seven, choose 7, which is 1. Okay, and after you simplify all of this out, I actually didn't see this in my notes. I had that on there, but, well, I didn't have this. I remember looking for a pattern, just didn't end up seeing it. But after you simplify everything, you should get 1,664 times the square root of 5. That is our answer. And on to our last problem. We have 9a. 9a is asking us to find the value of the following by choosing an appropriate value for x in the expansion 1 plus x to the n. Is that? Yep, to the n. Okay. I'm a little confused what it's actually asking us. Let me reread this. All these notes that I'm looking off of are like last year, a while ago. I'm just rereading most of them. Find the value of the following by choosing an appropriate value for x in the expansion. Oh, it literally, okay. Sorry, it's giving us the binomial expansion. I need to actually write this. I don't know if that's a -2, if that's supposed to be a negative. Oh, no, it is. Or minus. Okay, looks like there's a pattern going on here. Dot, dot, dot. Plus -1 to the r. To r times and choose r dot 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 -1 n 2 to the n times and choose n. Okay, let's see. I really hope you all don't hear that lawnmower in the background. Okay, obviously it gives us this first pattern here, but once we get down here, it's showing us that it decreases, so we go up and then down right after, which means the only thing that's gonna end up staying here is a -1 in each of these. So that should just be equal to -1 to the power of n. Right, yeah. 9b. If this is a bit confusing, then just like it's hard to explain it. It's in this side there's a negative over here, and that's the thing that's practically being that's staying in each of these. So those are negative, but that's gonna subtract out of everything, and we're just gonna be left with -1 to the n for our solution. 9b is saying that we have n choose 0 minus n choose 1 plus n choose 3 dot 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 plus -1 r times n choose r dot 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 plus -1 n times and choose n. Okay, let's focus on this part only, since that's just telling us what's going on over here. If it's adding, okay, this is going to be hard to explain, but notice how for this equation we're just going to have -1 to the r times c n minus r. This can either be equal to a positive or a negative number, but if this is equal to a positive number, then that means this side over here has to in turn be equal to if this is equal to a positive number, and this side, that means this side also has to equal to a positive number, and positive minus, well, it will be equal to the same positive number, and the same number minus the same other number is just going to end up equaling 0. So our answer is 1 minus 1 to the n, which is equal to 0. And that is it for today's video. I hope you all enjoyed.